Playing table football, are we? Nice. Good, busy. Yes, more games over there. All the games everywhere. So, we have a regular meetup, it looks like. Pizzas are here, and the beers are here, drinks are here, everywhere. As one of your organizers of Amsterdam.rb Meetup, I'd like to point out a few things. The restrooms, they're in the, usual location for you. Since we're in a meetup that always focuses on online, but now quite online, I can tell you that the code of conduct is still a thing for all attendees, for all speakers, for all the organizers. That is Rayta over there. We have Floor over there. Hi, Ivan, not an organizer, but he's very good as a host. Tom, behind all the machines, doing things to make sure we can be live. Also, I'd like to give a shout out to the pizza sponsor for this time. This is your employer because, well, I think you paid for it yourself, right? So enjoy your pizzas, they're good, I hope. But maybe you're just eating crisps, that's also fine. Let's get more serious. You may have seen that in the Slack, some new logos were presented. We have some, the old logo you may remember, but a new logo was designed by Svetlina, and not only for the Amsterdam Ruby group, but also for Rails Girls, and also for the foundation behind this thing called Stichting Ruby NL, which is actually those two over there. And we've created new logos to have a better feel. They're created by Svetlina. You can find her on Twitter. Also, she's just in the Ruby Netherlands Slack, so you can just find her there. Then I'd like to point out that in the last week there were some things happening in the Netherlands. Actually all in the world, everywhere in the world, but in the Netherlands also the Black Lives Matter thing became bigger. We had a wonderful get together in Amsterdam at least, but everywhere in the Netherlands. And also Stichting Ruby NL donated money to the Black Lives Matter because, well, we do think they matter, and we hope you feel the same way. You may have an opinion about it. I mean, the whole world has an opinion about it. Share it. Be vocal about it, but also be human and grown up about it. Because, well, if I can tell you one thing about how the communication like yesterday was about renaming the master branch into something else, I can say that we are, communicating as grown-ups. That was very nice to see. So even if you have an opinion about us donating money there, I keep it civil. We told you that at 7:15, Amsterdam time, Coraline will kick off with a talk, and then after the break that Anton will do a talk on Redis event streams. That's still happening, both of them, which is somewhat earlier. We tried to stretch it a bit by starting later, but you don't want to see me 15 minutes in front of this camera. So in a few minutes, Coraline will kick off with the talk about ethical source. I think it's somewhat related to a lot of things that are happening in the world, so I'm very happy to have her in this meetup. I'm very interested to see what she has to tell us. And then after the break, Anton with a talk about Redis event streams. Also something I care about because maybe it's just me, but I really like Redis over Kafka. So I'm happy to see more info on that because it's one of my pet peeves. This is the moment that we are going to go to Coraline from the United States. Actually, it is lunchtime there while we're already at dinner time. Coraline, over to you.
Hear me? Can everyone hear me?
We can hear you, yes. Yes, we can hear you.
Okay.
I can't hear you at the moment, but people with headphones are gesturing that everything is fine. So go for it.
Right. Let me share my screen. Can everyone see the slides now? I'm going to assume so. This talk is called The Rising Ethical Storm in Open Source. When I wrote this talk, I was very focused on human rights carried out by the government against immigrants and asylum seekers in the US. Now the world is paying attention to police violence against Black communities. I want to update this talk to reflect that reality, but I have a lot of work and reflection to do before I'll be ready for that. But believe me, dismantling the open source pipeline to police technology is also a priority. And I feel like it's okay because we can care about more than one thing at a time. Many of you may not know me yet, so I provide some credentials here. And many of you who do know me may not like me very much, and that's okay. All I ask is that you listen. In the 1960s, amidst growing tensions between the United States and the Soviet Union, a computer scientist published a short piece that he called The Parable of the Locksmith. This is my retelling of that parable. One day, a mysterious stranger walked into a locksmith shop. The locksmith had never seen him before, but he could tell from the way the man was dressed that he was well-to-do. He came to the locksmith with a proposition. He said, "I have a job that needs doing, and it requires someone with your highly specialized skills. I've done my research, and you're one of the smartest and most capable locksmiths I've ever heard about." The locksmith felt very flattered and more than a little intrigued. The man continued, "I want to hire you to open a certain safe. Never mind whose safe it is. That's none of your concern. Just do the job I hire you to do, and I will make you rich beyond your wildest dreams." The locksmith was excited at the proposition of such a lucrative job, but also a bit nervous about not knowing who the safe belonged to. It seemed suspicious. The stranger went on, "There are certain conditions you'll have to agree to. First of all, I will blindfold you and take your phone before bringing you to the safe's location, and you can never tell anyone that I hired you." This struck the locksmith as very odd, but he thought about what the man had said about making him rich. He felt like he'd struggled all his life, but was never properly rewarded for the hard work that he put in day after day. The stranger continued, "You can have all the tools you need to do the job, the very best tools. I will spare no expense. If there's something you need that you don't have, I'll buy it for you gladly. Take your time. I'll be back tomorrow for your answer." Despite his hesitation about the nature of the job, the locksmith spent all night thinking about his crummy apartment, his shabby furniture, and his daughter's dream of one day going to college. From the beginning, he and his family had learned to scrimp and save just to get by. Anyway, he thought to himself, if I don't take this job, he'll just go to another locksmith, the second best locksmith. He smiled to himself. The next day, when the stranger returned, the locksmith agreed to take the job. After multiple blindfolded trips to and from the unknown location, the locksmith finally cracked the safe. He wasn't allowed to see what was inside. The stranger blindfolded him again as soon as the lock clicked open. But true to his word, the stranger made the locksmith exceedingly rich. There's more to the parable, but we'll come back to it. The author of the parable then posed 3 questions. The first, was the stranger a criminal? Could the locksmith have recognized the stranger as a criminal? And did the locksmith do what was right? We're going to come back to this parable and find out what happened when the safe was opened in just a few minutes. But for now, I think it's interesting to consider these 3 questions as we think about software freedom as an ideal, as a guiding philosophy for the open source community. Over the past year or so, there's been a lot of discussion among software developers about our ethical responsibilities as creators, and the media has started paying attention to these discussions. Around the world, we're seeing technology being leveraged to commit human rights abuses on an alarming scale. And the technology powering these abuses includes free and open source software. Open source software today is increasingly playing a critical role in mass surveillance, anti-immigrant violence, protester suppression, racist policing, and the development and use of cruel and inhumane weaponry. And a lot of us are wondering how our work might be contributing to these atrocities. The fundamental question seems to be, are we responsible for how the technologies we develop are used? In response to these questions, we're seeing a huge surge of ethical source licenses, including a Hippocratic license. As creators, we can feel powerless and we want to find some way to do the right thing. We're horrified by what's happening in the world, and we're horrified of the thought that we may be contributing to it. But the conversation about ethics and computer science is not new. It's been happening in our field since before there was even any such thing as software. I want to introduce you to a man named Edmund Berkeley. He was one of the most important pioneers of ethics and computer science in the 20th century. Yet almost no one knows who he was. He got to start working on computers with the Navy during World War II. He published the world's first computer magazine and was among the first to propose the idea of a personal computer. He co-founded the Association for Computing Machinery, ACM, at Columbia University in 1947. The organization's charter reads, "We are an international scientific and educational organization dedicated to advancing the art, science, engineering, and application of information technology by fostering the open interchange of information and by promoting the highest professional and ethical standards." Berkeley sat on the Committee of the Social Responsibility of Computer Scientists, which published a report in 1958 on our social responsibilities. The finding of the report boiled down into 4 simple statements about the ethical obligations of computer scientists. First, that they cannot rightly ignore their social responsibilities. Secondly, that their social responsibilities can't be delegated to others. Thirdly, he cannot rightly neglect to think about how his special role can benefit or harm society. Computer scientists must consider how their special capacities can help to advance socially desirable applications and prevent undesirable outcomes. And finally, he cannot avoid deciding between conflicting responsibilities. Therefore, he must think how to choose. The report went on to say, when one reflects upon the great forces that computer scientists are associated with, it is no longer difficult to grasp and perhaps to accept our heavier than average share of responsibility. The committee believed that given the power and potential of computing, ethical considerations were paramount. The committee concluded the scientist's credo, knowledge for knowledge's sake, easily comes into conflict with our ethical responsibilities. Given human society in our century and the ethical value system we are using in our century, we can label some classes of work as obviously socially desirable and other classes of work as obviously socially undesirable, while admitting that there's a large middle ground which cannot be clearly classified. It was Edmund Berkeley who wrote the parable that I shared. Remember, it was the height of the Cold War when he wrote it. The parable ends like this. A week later, the retired locksmith saw a news headline about the theft of top secret military schematics. And soon after that, the stranger himself appeared on the world stage, declaring himself master of all nations, and he was backed by an army equipped with stolen superweapons. Berkeley goes on to address his 3 questions. First, was the stranger a criminal? For the answer, he points to the devastating wars of the 20th century and their corresponding atrocities, and the threat that the stranger made once the technology was his. Could the locksmith have recognized the stranger as a criminal? For this answer, Berkeley appealed to the Nuremberg trials after World War II to argue that exposure to Nazi activities provided a model for considering and condemning similar behavior in other people. It was clear that the stranger was up to no good. Did the locksmith do what was right? Berkeley contended that the locksmith had the responsibility to determine whether the stranger was a criminal before agreeing to work with him. So no, the locksmith did not do what was right. Berkeley concluded that the computer scientist does not have the right to shut their eyes in regard to their responsibilities, any more than the locksmith has. He called on his colleagues to shoulder their proper social responsibilities, and Berkeley was largely ignored. Fast forward about a decade. It's 1972, and the Vietnam War is raging. Berkeley and his colleague Franz Alt had been invited to address the ACM at a special dinner honoring them as founders on its 25th anniversary. Franz Alt's topic was reflections, and Edmund Berkeley was to address the more future-looking topic of horizons. While Alt's talk was celebratory, providing a retrospective on the advances in computer engineering and computer science since World War II, Berkeley's speech took on a distinctly different tone. He told the audience that anyone who is working to further unethical uses of computers, including the use of computers in developing weapons technology, should quit their jobs. He called out members of the audience by name. Many of his colleagues were so upset by his comments that they stood up and walked out in the middle of his speech. Interestingly, Admiral Grace Hopper, whom he had worked with during World War II, was among those who stood up and walked away. Berkeley concluded his speech by saying it was a gross neglect of responsibility that computer scientists were not considering their impact in terms of societal benefit or harm. And Berkeley was not alone in that sentiment. The technology historian Melvin Kranzberg famously wrote in the first of his 6 laws of technology, "Technology is neither good nor bad, nor is it neutral." Professor Lelia Green, who edited the book Framing Technology, Society, Choice, and Change, wrote that when technology was perceived as being outside of society, it made sense to talk about it as neutral. But the idea fails to take into account that culture is not fixed and society is dynamic. When technology is implicated in social processes, there's nothing neutral about it. The 1933 census in Nazi Germany used technology and services provided by IBM and proved to be pivotal to the Nazis in their efforts to identify and destroy the country's Jewish and Romani minorities. IBM was complicit in the Holocaust. The Nazis even shipped IBM punch cards on the trains to concentration camps. How would you feel if your work had contributed to IBM census technology? Other scientists in other fields face the same ethical dilemmas. World War I saw the first large-scale deployment of chemical weapons. The horrors of death by poison gas had repercussions throughout the entire chemical production world. Between the 1918 armistice and 1933, several international conferences were held to try to limit or abolish chemical weapons. And to this day in the US, no chemical manufacturer produces a solution used for death by lethal injection. After seeing the inhumane devastation of the atomic bombs at the end of World War II, atomic scientists actively sought to limit or eliminate the bomb's threat to human civilization. The Bulletin of the Atomic Scientist became the voice for the ethical responsibilities of physicists. And the Doomsday Clock project was launched and continues to this day as a reminder of the danger of doing nothing. And how did the computer science community deal with its ethical conflict and the realization that they might be complicit in genocide and other atrocities? They stood up and they left the room. And that shirking of responsibility is pervasive in the free and open source world today, too. How would we feel about the complicity of IBM if their punch card system was licensed under the GPL? Because that's exactly the situation we're facing now. In 1998, when the open source definition was penned, the greatest evil conceivable by computer scientists was the market domination of Microsoft. The founding thinkers responsible for free and open software had overwhelmingly libertarian political values. They very clearly understood the impact of technology on society. But rather than using an ethical framing, they chose to focus on the impact of technology in commercial terms. The libertarian platform specifically centers the freedom of individuals over the greater good of society, just as the open source definition centers the freedom of software over the greater good of society. Thomas Kuhn argues in his seminal book, The Structure of Scientific Revolutions, that science is always practiced within political contexts. Scientists do not operate with complete freedom. They operate within community and societal constraints. He writes that paradigms gain their status because they're more successful than their competitors in solving a few problems that practitioners have come to recognize as acute. The acute problem that open source set out to solve was creating opportunities for independent software authors to write, promote, and share their software without the threat of monolithic corporate domination. And it's been wildly successful. But that's not the existential threat that we face today. In 2020, we face evils much greater than Microsoft market domination. We're in an age where governments are carrying out programs of mass surveillance, using facial recognition to interfere with legitimate political protest, and using technology to carry out state-sanctioned genocide and violence. And open source software is being used in part to power human rights violations like this. In the US, Immigration and Customs Enforcement, known as ICE, is separating children from their parents at our border and putting immigrants and asylum seekers in cages without access to medical care, legal assistance, or due process. There's an estimated 40,000 people in ICE custody today, and there have been hundreds of documented deaths in these concentration camps, most of them due to gross neglect. ICE is the officially sanctioned agency carrying out Donald Trump's white nationalist agenda. It's the modern equivalent of the Gestapo. And US tech companies are winning billions of dollars in contracts to support ICE's programs of terror. Are we also going to get up and leave the room when we're faced with our own role in human rights abuses like this? And open source's complicity in human rights abuses isn't a bug, it's a feature. This is by design. The open source definition allows for the use of software for any purpose, explicitly including for evil. They write in their FAQ, giving everyone freedom means giving evil people freedom too. Under what other circumstances in human society do we grant complete freedom to evil people? We arrest them, we imprison them, we bring them to justice however we can. Sometimes we even go to war against them. Bruce Perrin, who some call the father of open source, gives voice to the core open source libertarian conceits. In a 2019 blog post attacking the Hippocratic license, he tries to sweep ethical concerns under the carpet. He writes that the definition of what is ethical changes over time from place to place and from one individual to the next. In fact, Freedom Zero was specifically written in response to his feelings about the Berkeley Spice license, which prohibited the use of its software by the apartheid-era government of South Africa. But the ethical framework of the Hippocratic license, which he's reacting to in his blog posts, is not slippery and not subjective. It doesn't change from person to person or place to place. It's tied to the founding document of the human rights movement, drafted by representatives with different legal and cultural backgrounds from all regions of the world, and proclaimed by the United Nations General Assembly in Paris on the 10th of December, 1948. Like Berkeley said, some things can be labeled as obviously socially desirable, and other things as obviously socially undesirable. And yes, there's a wide swath that is subject to interpretation, but human rights are not subject to interpretation. Perrins also says that licenses aren't the right vehicle for enforcing ethics. I believe that licenses are the only tool that the open source establishment has made available to us. So of course, we're going to hack them to fight for human rights. Around the world, open source developers are starting to recognize their ethical responsibilities that we've ignored for 20 years. This is the beginning of a movement. Kuhn writes that scientific revolutions emerge when people observe a fact that calls into question established theories, and these practitioners work to create new theories to address the anomaly. That's what we're seeing now. That's where we are today. He wrote that the conflict between the established and new paradigms can proceed in one of three ways. The first possible response is procrastination. In the face of the ethical crises that we find ourselves facing, procrastination is not an acceptable option. The need is too urgent. The second possible response is assimilation. The establishment accommodates the new idea and adjusts to it in a conflict-free manner. And this is my ideal outcome. I want to give the open source establishment the opportunity to accommodate ethical considerations by challenging the narrow perspective of Freedom Zero and the open source definition. The most extreme result of the conflict between the establishment and the new paradigm is revolution. And if the free and open source software establishment refuses to change, refuses to reconsider its hardline position on ignoring ethical responsibilities, revolution will come. Kuhn describes revolutionaries as being motivated by solving a different problem than the establishment has previously prioritized. The current debate is whether solving the problem of software freedom is more significant than solving the problem of how technology can be used to promote human freedom. In 1999, UN Secretary General Kofi Annan announced the United Nations Global Compact. It's a pact to encourage businesses worldwide to adopt sustainable and socially responsible policies. It's the world's largest corporate social responsibility initiative, with 13,000 corporate participants and stakeholders in 170 countries. The very first section of the document deals with human rights. It states that businesses should support and respect the protection of internationally proclaimed human rights, and that businesses must make sure that they are not complicit in human rights abuses. Complicity means being implicated in a human rights abuse that another company, a government, an individual, or some other group is causing. The risk of complicity in human rights abuses is higher in countries with weak governments or where human rights abuse is widespread. But the report emphasized that the risk of complicity exists in every sector and every country. Complicity has two different contexts. The first is providing goods or services that a company knows will be used to carry out human rights abuses. The second is when a company benefits from human rights abuses, even if it didn't assist or cause them. With these definitions in mind, in 1972, Edmund Berkeley stored the hornet's nest by calling out his colleagues who were complicit in shirking their ethical responsibilities, and they walked out. I'd like to follow in Edmund Berkeley's footsteps. I want to call you out. I want you to pay attention to who walks out or disengages in the next few minutes. Amazon routinely violates international child labor laws, actively works to suppress worker organization, and has millions of dollars in hosting contracts for the US government's anti-immigrant agencies. If you work for Amazon, your company is complicit in human rights abuses, and it is your ethical responsibility to either organize to change the company or quit your job. Microsoft contracted with the Chinese government to work on facial recognition programs that they used against their population, and the company proudly proclaims in a press release that they're selling Azure government to ICE. If you work for Microsoft, your company is complicit in human rights abuses, and it is your ethical responsibility to either organize to change that or to quit your job. IBM has received $1.7 billion in contracts from ICE and Customs and Border Protection since 2008 to support the U.S. government agencies responsible for harsh enforcement activities and illegal treatment of immigrants and asylum seekers. If you work for IBM, your company is complicit in human rights abuses again, and it is your ethical responsibility to either organize to change that or quit your job. If you work for any of these companies, your company is complicit in human rights violations, and it is your ethical responsibility to either organize to change or quit your job. Let me make my position perfectly clear. As software professionals, we have an ethical imperative to prevent our work from being used to harm others. Freedom for freedom's sake is incompatible with our responsibility to society. Software freedom must not come before human freedom. There's a blog post by Stephen Wally of Microsoft. He wrote that if people want to challenge the core principles of open source, he thinks they should be bold and courageous. In February, before the outbreak of coronavirus took the world, I flew 4,000 miles to give this talk to a copyleft audience, most of whom don't like what I stand for, don't like what I'm trying to achieve, and don't like what I believe in. I'd say that's pretty bold and courageous. And yes, we are defining a new movement. It's happening right now. It is global. The point is, the way that people just like you react to the question of ethics and open source will determine the future of our community and our movement. You have the power to influence what happens next. If you're in the procrastination camp and think you can put the question of ethics off, you're in for a big disappointment. These issues are not going away. If you want peaceful resolution, you're in the assimilation camp. So you should work with and encourage our existing institutions to revise and expand the open source definition and the associated licensing processes to pave the way for ethical open source. And again, for me, this is the preferred outcome. But if you refuse to acknowledge, let alone to address, the ethical shortcomings of free and open source as it stands today, then the only option we're left with is revolution. A proprietary print driver sparked a massive paradigm shift in software development. Richard Stallman saw what he perceived as an ethical problem and created a brilliant way to solve it with licensing, and that was an epic hack. Today, we have much bigger ethical problems than proprietary software, and it's up to us to come up with another epic hack to solve that problem too. Stallman wanted a printer driver. We want kids out of cages. That's what the revolution is all about, justice. As Berkeley said, we cannot avoid deciding between our conflicting responsibilities. Therefore, we must think how to choose, and choose wisely. We are all locksmiths, and the world is full of strangers. If you want to join us in working towards solutions to the ethical challenges we face today in open source, I encourage you to go to ethicalsource.dev, read through our materials, and consider joining the working group to collaborate on ways to resolve our crisis of conscience. Thank you for listening.
Switch naar mij. Well, thank you very much for your talk. I'm hoping for the audience to have some time for questions. organizers are making sure I can see them, by the way. With ethical source dev, Coraline, I'm asking you specifically, what if only one thing would be a contribution you would expect from us, your audience, today?
Really, the main thing I want you to do is think about how the software you produce is being used in the world, and consider if you want some kind of control over how your software is used. I really believe that for too long we've written software and thrown it over the wall, not paying attention to how people are using it. So the first thing to do is to start paying attention, and the second thing to do is to ask how you can prevent the code that you write from being used in such a way.
Okay, thank you very much. By the way, if you have some questions you want to ask Coraline, feel free to share them either in YouTube or on the Slack channel Amsterdam, or in general even. I have, well, David Kelly, he mentioned that with Clearview AI, that, well, they create an image of technology being used for good, but it's actually being used like something you'd see in a bunch of Black Mirror episodes. Do you know that company?
I don't know that company, but I'm not surprised. All of the big tech companies are in with governments around the world who are using the software to create terrible acts of violence, and the companies are willing to go along with it for profit. So it's not surprising that in our capitalist systems that we are facing issues like this, and that we're seeing companies doing things like that. And really, it's up to us as the employees of those companies to lobby for change. And it's on us as software developers to make sure that we're not contributing to the atrocities that they are committing.
Okay. Just looking at the organizers. One question?
Apart from making software, using your dollars to put them to the right cause as well.
Did you hear the question?
Voting with your dollars.
Voting with your dollars. Yes.
Voting with your dollars is another way that you can contribute. It's hard to bring about large scale change through boycotts, unless the boycott gets to a critical mass. But there are things that we can do as individuals to help. For example, I'm a musician and I've released 6 albums, and I used to make my music available on Amazon. And as soon as I learned that Amazon was collaborating with ICE in the US, I pulled all my music from Amazon. And on my band's website, I still have the links to Amazon, but instead it goes to No Tech for ICE.
Okay. I think that's a very clear example. I'd like to thank you very much for your presentation. We are going to go in a break of 2 minutes. We'll see you back after the break. Get yourself a drink, and then after the break, we'll have Anton's presentation on Redis event streams. Give me 2 more minutes. Well, thank you for giving me 2 minutes to get myself a fresh drink. I hope you have your fresh drink. And now it's time to give the floor to Anton, who, by the way, works at a company I built the first bits of software, as far as I know. So if you see my very unexplanatory commit messages, sorry, Anton. But now the floor is yours, and please talk with us about Redis event streams.
Hello, everyone. First of all, it was a really amazing talk right before me by Caroline. Really liked it. And I also would like to start my presentation first by saying thank you to organizers. It was everything that goes backstage is actually pretty good. So first, what I'm going to be talking about today is Redis streams. We're going to be go through how you can use them, how do they work, some considerations. So maybe you're going to get inspired for using them in the future. So my name is Anton. Here at the bottom of the screen, you can see my Twitter hashtag, my website, and where I work at the moment. And indeed, I have seen a few comments by Arno. They were good. They were good. Don't worry, Arno. All right. So to start this talk, for a while I was thinking, how can I tell it in an engaging way that you can follow it? And why I had this issue is because it's going to touch for the different points. It's going to go. Basically, it's going to go in 3 lines, and I want you to be able to navigate for it. So as this is a bicycle that was already invented, it's called legend. So every single map has a legend, and this talk also has a legend. So the legend for this talk is the following one. If you see the white background on your screen, then it means we're going to be talking about Redis. If it's somewhat yellowish background, then it's a shameless plug of mine. It's a Ruby gem that I wrote that works around Redis streams. And if you see the dark background, it means time for the terminal, and we're going to switch to the demo. I was told that maybe dark colors doesn't look good on presentation, so I kind of realized that right before we started. So I decided not to change it, otherwise things could go really bad. So I hope everyone has a screen, so it's not going to be a problem. Otherwise, I'm still going to be talking about this, so you should be able to follow. Okay, so why am I giving this talk? And the answer to that is actually, I decided that I would like to talk about Redis streams in November last year. And that was because I remember being at one of the previous meetups, and Tinko was talking about domain-driven design. And to showcase, he used an event sourcing. And to do the event sourcing, he pulled out Kafka, which is a huge monster for demo, is my humble opinion. And that gave me an idea that I think not everyone knows that Redis from version 5 came out with a new data type, which is called Redis streams, which allows you to achieve something similar to what you can do with Kafka. All right, so why you want to use streams and why Redis streams? So first of all, streams is useful data type. It's a Panda-only data type, and we're going to go a bit more into what is a stream, what is unified log, and how you can actually visualize it for yourself and have a better idea how to think about this. Another thing is, which is more into the bucket of Redis. If you compare the memory footprint of Kafka and Redis, even for the same message, Redis manages to quite compactly store the data. And even though it's in memory database, it actually manages to support quite a big streams of data. And another thing, which is probably the most important one, is most likely Redis is already part of your stack. You're probably using Sidekick, so it should be already there. And it's no surprise that you can go to Heroku and get Redis there with for free. While I think Kafka right now costs, I think the cheapest one is around $100. All right, now let's try to look what is a stream. So first explanation for a bit more terminal folks. You can imagine that stream is a text file where you just append data. And the way you can imagine this is you can use your tail -f, and then when you see logs, they just being printed out. I give, here's a few examples how you can do that. And that's pretty much the stream. It's a text file. For a bit more visual folks, I pulled out this image from the URL listed below. By the way, very good article. And the way I like to imagine stream is if you can picture in front of you the old film, where each frame of the video is represented as one picture. And by itself, one picture doesn't tell you the story, but the whole sequence tells you the story. And you can imagine that the stream is those frames that you're just adding data to it. For example, as this YouTube stream is doing pretty much the same. Right now, what I'm saying is being turned into the frames and audio bytes, compressed, and so on, and being appended to the list. And now, if you scroll back in your YouTube, you're able to go back and see something there that been already said, or you can go and watch it live as the items is being appended to the list. Redis stream is implemented with the three main components. You can let's call them components. One part is the streams itself. So basically, streams is a data type that you can use in Redis, which allows you to append key value pairs. So you can imagine that being like an array of hashes. And another thing that is, and the most interesting part about this is what was added on top of that is called groups. Groups is basically your pointer on your video where it actually records what you are watching at the moment. And you can pause it and you're going to be remembered where you stopped. And I personally see that as very interesting shift in the Redis itself, because Redis usually was quite as stateless about the client itself. But from introducing groups, you as a client can actually tell where do you stop reading in Redis. And the whole relationship pretty much looks like this. You have a streams, you have a groups, and you have a consumers. And groups have multiple consumers, and stream and group could be attached to the stream. But I think nothing could tell more about the Redis itself, as was said by the Salvatore, the creator of Redis, and I'm just gonna read it out loud. I don't think most of the Redis community is understanding what paradigm shift Redis streams are, because the feature is seen from the perspective of view of streaming, like a Kafka. However, most of the value is as a pure data structure. As I was trying to point out in the previous slide, that if you are not thinking about groups, it's still Redis. It's still data type that you can use to do your thing. All right, now we change the colors. If you remember the legend, that means we're going to be talking about Gem. So I have created a gem which main idea is try to make Redis stream feel like they were made for Ruby. And basically, when you're gonna see further down the road, it tries to act like an array, like the same way that the philosophy of Ruby least surprise, it will try to be the least surprise for you. Okay. All right, let's imagine that you're sold, like you're interested. So let's go through and see how you can use it. All right. So the first thing you want to do, of course, you want to create the stream. So that's done like in any other operation in Redis by putting the data into the key, and that's acts as a creation. So for that, there is an operation exists called add. Every single stream operation starts with X. Just a heads up. By default, if you don't provide an ID, then Redis will generate an ID for you, which is timestamp and the digit, which digit represents how many times, how many IDs has been created within that timestamp, which is, I think it's pretty good idea, because then you can keep the counter per second. And I'm thinking that's it's a nice trick to have in your sleeve if you ever need to generate random IDs. And the rest of the data is consists of the key value, almost the same as you can do with the hashes. All right. So how can we do the same thing but with gem? So we can define our transactions, and then you can, the same way you are appending data to your array, you just do that. That's pretty much it. Now, the dark screen. All right, so as we're going for this presentation, I was trying to make a visual representation of it as a movie. So we actually going to watch in a movie. It was done, I think it's unbelievable work by Simon Johnson. I hope I read in his surname correctly. He created a 17 minutes Star Wars made with ASCII art. So what we're gonna try to do is, first we're gonna try to, basically you can imagine there's a file where we have all the data dumped there as a text, which consists of 2 parts. It has the duration and what should be displayed on that frame. So duration is going to be how many intervals does the same frame is copied, because we want to keep less logic on the player itself, but more on the broadcaster. We basically gonna take that duration and replicate as many times. So we're gonna have copies of the same data for each frame. This is basically the example of how approximately the code looks like for that. So we're gonna switch to our console, of course, and here I have the first Ruby script prepared called broadcaster. We're gonna launch it, and we're gonna go to our Redis CLI, and one handy command which exists in there, it's called xlan, which you can take a look how many messages are stored in one particular stream. So our stream name is movie. Missing some space. So right now it's 12,000 already. Should be about 16, 17,000. Okay, so 1655. So that's about 17 minutes approximately. So our whole movie was loaded. So, and we're gonna go back to our presentation. All right, time to talk about Redis again. The way, as soon as you loaded stuff, I think it's time to read. So There's two ways to read things from Redis, from streams. One is non-blocking way and a blocking way. And non-blocking way, basically it means it's not gonna keep your connection open and waiting for the message to arrive. So the way you do that, you can use the commands listed here. You can provide the name of the stream. In this case, it's transactions. And then you provide an ID of the last item you have seen. So if we're going to start with 0, it means we're going to start from the beginning of a stream. In the second example, you can basically provide multiple streams and read them at the same time, basically one by one. And the blocking way is you give it a timestamp. You give it a time that you would like to wait for, and you provide a stream. And instead of ID, you can still provide the same ID of 0, but there is a special ID which is used, means a $sign, which means take the last delivered ID that I have seen and use this one, and everything that comes after that, let me know. When should you use blocking? When you should be using non-blocking. However strange that might be, but blocking one is something that you might want to use if you have lots of clients. Why? Because usually the Redis itself is a single-threaded, except for the blocking operations. What the blocking operation does, it moves your connection in the more synchronous way, and it actually allows other clients to do the writes. While non-blocking operation will be performed, it's basically going to be do the lock and check if there's anything there. While if you have a writing client at the same time, it will be waiting for the read to be completed. So there is no read or write queue. All right, how do we do it with Ruby? All right, pretty much the same. We define our stream called numbers. We add 1, 2, 3. We want to get it as array to A. Want to get a sum. Basically, the stream implements enumerable mixin, and means you come with everything that Ruby array can do. You can get the minimum, you can get a maximum, you can iterate over it, you can map, and so on. Now, time to go back to the demo. What we're going to do right now is, you remember from the previous part of the demo, we loaded data in our movie stream, and now we're going to play it back. So what we're going to do, we're going to take our Redis stream and we're going to iterate over the data that is inside of our stream, frame by frame. We're going to clear the screen, we're going to print it out, and then we're going to wait for duration of the frame. Originally, this video, like this ASCII movie, was created for the frame rate of 16. So that should be quite enough. And I'm pretty sure that the frame rate of this stream is higher than 16. So it means that you should be able to see everything as I'm going to see it. So should we get started? All right. Okay. So what is happening right now? We're actually reading frame by frame from our stream and put it on our screen. This is, I think about this as one of the best illustrations of what the streaming actually is. It's frame by frame representation of your data. I would love to put here a proper Star Wars audio, but I'm sure that Disney is not going to be really happy about this. And my mumbling and singing of the Star Wars theme song is terrible. I tried it right before the talk, so I'm gonna not going to do that. So now, what's current problem we have? So if we can basically terminate our application, we're going to start over again. It basically starts from the beginning because we take the stream, we iterate over the items. Now let's look how we can improve on that and introduce other parts of the Redis stream. All right, groups. So there's a few operations that you can perform in groups, pretty much the same as you should be seen before. We can create a group where we give first the name of the stream, the name of the group, and the last scene ID of that group. So for example, this $sign means I'm going to read from the end. If I want to destroy, pretty much obvious. And changing the pointer is that I can set an ID of my group. So if in case I would like to play it over again, I can set it to 0. Now, yes, and now if you want to do the same with Ruby, pretty much like this. I'm so far not really happy about this API, to be honest, especially with the destroy part. So if anyone has a good ideas how to make the API a bit more Ruby-like, and at the same time provide a clear way to delete the group, all welcome for ideas. All right. Now, how are you going to read it? If you remember from the previous example, with the operation for reading was xread. This is a basic xread group where we provide the name of a group. Then we provide as a player one is actual definition of your consumer, because Redis tries to identify what kind of consumers have seen that. So you can use either the same consumer name to get the same data, or you can actually basically try to scale it by having multiple players consuming from the same group. Right. One other magical ID that you can see here is this little pointer to the right. It means the same thing, show me everything that I haven't seen. However, there's also 0. And as we talked, groups are remember where they have stopped. The difference between arrow and the 0 is the following one. Every single time consumer takes a message, they need to tell back Redis that I have consumed it. And if you provide a 0, it gives you all messages that you actually didn't accept yet as well. So you can actually go back and play back the things that you have failed, for example. All right, how we're going to do it with our Ruby part. We create our group. We get our consumer, which again returns us exactly the same thing as we had with the stream. We iterate, we play back. All right, let's give it a shot. All right, so here I have my other type of player that I have prepared. All right, I'm gonna pass our reset. Right, so it started playing, same thing. Now if we're gonna try to run the same player, as you can see right now, both of those players are playing at the same time. So we are reading the data from the same stream one by one with the 2 different clients. This is basically how you can imagine your round robin type of scaling can work. Now let's imagine we kill our clients. If we're gonna start them again, they're actually gonna start from the same point where they stopped, and you can continue playing. So finally, you can have a bathroom break while watching this amazing Star Wars episode. All right, what if there's someone else joining to watch the same movie? How can we do that? The way to do that is to have a different group. So you can have the same different groups attached to the same episode, no, or to the same stream. So for that, I did a small params that we can pass group, and let's call it player 42. We play it out. So now there's two separate consumers with the two separate groups consuming the same stream. And if you can imagine, let's say the one on the left could be slower listener, slower consumer, another one is a faster consumer. And this is how you can probably want to go around if you have consumers that process things at a different speed. So let's stop it. All right. Let me have some water. All right. So some conclusions about what you have seen right now. The first one is, as I said already, if you have multiple groups, if you consume data from your stream at the different speeds, use multiple groups. If you want to load balance your reading operations, use multiple multiple consumers, of course. And one of the last parts that is interesting to explain is, imagine you have a scenario where you want to ensure that you read things only once. If you have multiple consumers that are subscribed to the same stream, and one of them fails, basically, if you're going to start the next one and you provide in the ID 0, you will basically try to reread this message again because it was never accepted, and it's going to be retried already by another consumer. Not exactly, that doesn't really need to be consumed by exactly the same one. And if you have requirements where you want to guarantee that message is consumed once by the same consumer, you most likely want to have multiple streams with the duplicates of data. Then you can guarantee that one consumer or one group is subscribed to one stream and another one is subscribed to another stream. So you're basically creating duplicates of data, but you can guarantee one read. Now, of course, there's a beast in the room called Kafka, and we cannot go about not mentioning it. And the thing here is when you should still pick Kafka. First of all, if you produce lots of data, imagine that if you're running your Redis part, and the amount of data that you produce is far exceeding your memory capacities or how much you would like to allocate for your memories, then maybe Kafka is still a better choice. If you have a different consistency guarantees, then Redis can provide. However, even if you can get pretty far with Redis. Like, for example, there's a few settings that you can set on its part, which allows you to make Redis not be eventually consistent. So basically, it's first checks if my children have copied my data, and if they did, then I tell to you, right, everything is good. However, no matter that, there's still chances that data could be lost. And one thing that's also related to the consistency here, if the groups are also shared amongst the the nodes. So if your master node dies, Redis will still remember where you have stopped. If the problem that we described in the previous slide, where you want to guarantee the one read, Kafka partitions are pretty much made for it. And if this is your main requirements and you don't want to invent your own things to make it work for you, then maybe Kafka is still there. And of course, as almost the very beginning of this presentation, if you're already using it, most likely you should still use it. And that's about it. We're going to go to some, if you have some questions, I'm happy to answer them. I'm going to right now minimize my presentation. Sorry. Yeah.
We have some questions. Anton, David Kelly asked, so I've seen you using it to stream SKI out, but what are you using Redis Stream for at work or other personal projects?
We use it at work. So in the situation was the following one. We had we were integrating with a third-party system which provides us with events that are happening. However, they persist their events for only 24 hours. For us, we're basically taking those events and kind of distributing it through our system. But there was a case where we wanted to collect events for longer enough in case we want to play them back. In case things fail, then we can play back data for at least the last few days.
That makes a lot of sense.
And that was a good case for it because the consistency there was not that big an issue, and at the same time, it gives you an extra things to basically save yourself.
Okay. We had a question from Thijs Kadeer. How do you look at scaling Redis itself? Is it feasible to run lots of Redis instances or something like that? So do you have a suggestion?
I wish I had a very good answer to this one, but I'm not. I have an experience of somewhat decent Redis stack. But at the time, I was not using it particularly with the Redis streams. I think the best way for Redis to go about is just do your own sharding. Basically, have a different Redises for your different data, if you can split them. And another thing that's particular I can imagine about the scaling part. I mentioned the part about making Redis consistent. You most likely want to make Redis a bit more eventually consistent. Otherwise, you're kind of limiting yourself to basically all your nodes on the Redis cluster will become one single mutex, which locks everything and then unlocks until your operation is complete.
Yeah. Okay. And David Kelly is also interested in, he probably has something running on Redis 3, next to it something running on Redis 4. He wants to know if you have any suggestions for upgrading it to Redis 5, because, there are some incompatibilities there.
I wish I had an answer to that, but I actually don't. I don't really know. Never had to do that.
Well, it's a bit like the previous question. I'm sure other members in this community are running Redis at different scale, potentially even multiple versions. As in upgrading from one version to the next. So feel free to ask your questions in the Amsterdam channel in Slack. And it's not only Anton who should answer these questions because we're here now with all of us. So pick another beer. Talk to each other on how to scale Redis or how to upgrade it. Also, I noticed that there is some pizza left, so grab yourself a bit of pizza and just enjoy the rest of the evening. Talk to each other as it is a regular meetup. And I think I'm just going to enjoy myself now playing table football. Doei! I'm just hoping that they are removing us from the stream. Did you remove us from the stream? No, you didn't.